wanted to do I really wanted to do the subject of note-taking and test writing, specifically for the maths and sciences. Okay? That's my main concern. So, a lot of you are in the electronic age, and a lot of you don't use it, which is a shame. You have such a valuable tool here, but I'm going to teach you right off the bat. Number one, memory is gained by doing, not by watching or even reading. And that's why every school encourages, unfortunately, the repetitive note-taking system, which is repeat, 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 and you will remember. Repeat, repeat, repeat. It's very true, unfortunately. How did you walk? You tried to walk 1,000,000 times, and eventually you walked like everybody can, which means everybody was capable of walking and learning how to walk just by doing it every day. So I'm going to teach you both the electronic note-taking, which is good, but I'm also going to explain this. When you write by hand, in pen, in a note, you are far more likely to remember it than copy and pasting from electronics. And even then, here's the other fact, even if using a laptop in class, suppose you can type much faster than you write, I don't blame you, I would use a laptop nowadays, you will remember a lot more by typing. They say that when it's something that's factual, learning how to spell is good, typing is better. When it is operational, handwriting is better. Okay? So, it's up to you. But whether you type or you write, it's far more better than copy and pasting. I'm going to use copy and pasting in this video to show you sort of what your notes should look like. Okay? But overall, when you learn to handwrite something into your notebook, you will remember it better. When you handwrite into your notes, you will remember it better. So if there's one thing I want you to gain, it's this. Second, keep a master notebook of each chapter's concepts, each section's actually, every chapter's broken down, including chemistry, biology, and key formula. Often there's a key formula with one clear example that you understand. Then keep a separate notebook for your problems from the book, and keep a separate notebook. Oh my God, you're saying, what are you talking about? So you can skip one of these, but I'm going to tell you, if you do all three, you're increasing your percentage huge for class notes, which are messy, which are always messy, right? Ideally, when you get home from this should be reinforcing both that and that. But you know you do chicken scratches in class. When you come to your test, you're not going to know what the heck you wrote. Oh, so much time, man. The 5 minutes you take here saves you the 60 minutes of your lousy cramming. That's what I never understand. You know you fail when you cram. You know you do badly when you look at chicken scratches. Doing the same mistake over and over again is your problem. Take the 5 minutes to do this, and you'll be much happier when it comes time to study, even if you have to cram, okay? So, what do I mean by master notebook? What do I mean by problems? Well, this is straightforward. So at the end of every section, suppose you don't have any time or you want to learn at your fastest, go straight to the exercise section. Every science book and every math book has this. So this is after you page through your entire book. You should get an idea of how many chapters and how many sections. That's huge. You're going to save yourself so much stress and do so much better doing that. Say, okay, I don't have time to study. Jump straight to the exercise. Start doing it. Go, I don't know how to do that. So here's something. Math is a foundation thing. Chapter 1 is what you need to learn chapter 2. Chapter 2 is what you need to learn chapter 3. Last year's functions, what you need to learn calculus. The functions before that's what you need to functions. Math before that. So if you can't add 2 plus 2 and you're taking grade 12 functions, you might have a problem. But let's say you have correctly read 1.1 and you do understand sort of what they're saying. Just start. Just say, okay, I know what they're saying. Keep a copy of the answers separate over here so you're not flipping back and forth, or keep Desmos open so that you can just test your answers quickly. and then just confirm that you got the right answer. Write it down in your notebook. And you don't just do these in your head. As soon as I knew a student who used to try to solve these in her head, useless. You're losing. Don't even bother, I would say, because you can't remember what you did, how you did it, or what it means when you've gone on to chapter 4. And on the final exam, all these chapters matter. Then as soon as you can't do a question, go up into the chapter and you'll find an example. Always you'll find an example of how to do it. Follow along. Still can't do it? Punch in YouTube. How do I take a derivative for a log function? Someone's there who can explain it much faster than me or your professor. Because this sometimes is gobbledygook. So one thing I'll say about some notebooks is they don't do the summary well. But this notebook, for example, in calculus, does excellent examples. So they don't do the summary of the note well. You know, sometimes that looks messy. But they do excellent examples. So you go back, you do a YouTube video, and then you go back and solve the problems. But you must take a note of how you did it, you know, in your homework notebook. Once you get the idea of what you're studying, this is a fantastic thing. So by the time you do the answers, you will have a good idea what this means. So this is the kind of thing you should copy into your notebook. You should say, okay, well, section 2.5, derivatives of a log function. Okay, and then you have that. And then what should you do after that? Well, ideally, you should handwrite, not note, not just copy and paste like I'm doing. You should handwrite one clear example. So this would be it, and it must be clear. It must be clear. So you do something like that, and in this case they have 2 solutions, but whatever. And then you would handwrite this example over here. Boom! Your master note for section 4.5 is done. The reason you handwrite it is because you're training your brain to do the problem. That's what you're doing. You're training your brain to do the problem. And you should even do the Richard Feynman, looking up, famous physics professor. Incredible. And he used to say, if you can teach someone what you just studied, you will identify exactly how well you know it and what the holes are. So ask yourself, could you teach a total stranger how to do this? And obviously, like your mom and dad who don't have any calculus, that can't remember anything in calculus, see if you could teach them, because obviously you're going to have to teach them this, plus some other concepts, plus some other concepts, plus some other concepts. But ask yourself, could I teach someone how to do this? You will identify your holes. That was great advice by Mr. Feynman. And just keep doing it until you yourself can say something that someone else could understand. So what else should you do in here? So if you don't have a good example, and guess what? Most people cannot remember that good example later on when they've done 9 chapters. So I love this. So I used to do this for my students. So it'd be like step 1. Identify, read the question essentially. Step 2, understand what's being asked and the units. Step 3, so in this case you would separate each function into its own f of g. So label one function as f of g, and then somewhere else on this page, or f of x, label other function as g of x. 5, figure out the derivative of both. So derivative of both. So somewhere on this page, for instance, and let's pretend this example isn't here, or that you have this, oh, did I just crash? Or that you have this on a different page. This is what I mean by it. So I'll just use that example maybe. Determine the derivative of this. Okay. So your first step would be saying, okay, this is my f of g, or f of x rather, sorry, my f of x. And then I would make sure I have the number 3 here. so that I correspond with the step. Okay, label the other function as g of x. So I'm going to actually call g of x u. Okay, I'm going to call u. Boom. And I'm also going to remember over here, so that might be step 5, right? Or somewhere in between there. Establish u as internal function of g, something like that. And then somewhere else I'm going to have u is equal to, and what I replaced it with, which is this. Okay. Now, all along as I'm doing this, I'm going to put the number and the steps associated with these steps. And guess what? Once you learn the rule of math, that's the beauty of math. It applies forever. Okay, there are sometimes exceptions. There's more exceptions in chemistry and biology, but for math, this is very true. So if you have this clear step-by-step process, especially there's math illiterate people who don't quite get it, do the step-by-step, learn the step-by-step, follow the step-by-step. Clearly there's going to be some other problems where the step doesn't quite work. Also be aware that your teacher might give you stuff internally and you have to work backwards to figure out something. Like he might not tell you what f of x is, but he'll tell you the final answer. So you have to work backwards in your steps to figure out this part here. But so long as you understand that that's all math is, it's a fantastic way to do it. And again, do it by hand. That's how you'll remember it. So even if I have the steps from the notebook here, transcribe it by hand very clearly. Call this your master note for section 2.5. Then here's the other tip. You're going to take a test. Your teacher's going to use the textbook. Primarily, they use variations of the textbook answers. That's why they're here. When you jump straight to these questions, you're going to understand what the chapter's about, because they're only going to test you here on what matters. Don't even read the chapter yet. Jump straight to section 2.5. Learn what they're asking. Jump to the summary. Look for highlighted examples. Back here, example 3. Oh, look for stuff like that. Well, that's for graphing calculator. But right there, there's the big summary of it all. We've got to take the chain rule for the internal and then take the derivative of the internal, right? And then as soon as you learn those steps, and then they kind of give a step-by-step here. Some stuff you don't use. Sometimes you just have a working formula for what you need. But if your teacher asks you to simplify, yeah, you should learn how to simplify. I don't know how to simplify. Well, these things are the things you learned before. If you don't, YouTube something. How do I simplify something like that? Or punch it into Symbolab. Symbolab does step-by-step. Sometimes they block a step, and here's the secret to Symbolab. Take where they started blocking it and punch that into Symbolab again. Symbolab has a little fault where they'll reveal those steps and then block some other step and then do it again. And you'll eventually see all the steps needed to factor or simplify. And it's very crucial that you sort of understand what's going on. And if it's still not clear for you, that means you need another example. And you keep doing the examples on a different notebook until you have a master example. And I'm sorry, you might say, well, that sounds like it takes a lot of time. Do you really think you're going to be able to understand this the night before if you can't do it now? No. Take 15, 30 minutes to understand this concept, to take the proper note. Note-taking isn't part of studying. It's an additional resource requirement. So the problem solving that I did in the other video is a whole different 15 to 30 minutes. This is a whole different 15 to 30 minutes, but you get good at it. And you might say, well, forget it. You're telling me more time than I wanted. The time you spend here, 20 to 30 minutes, taking a note, will save you 6 to 8 hours of paging through and repeating the same problem. I have many students who forget what I teach them because right after the tutoring session, they go party or have fun. So it doesn't stick. So we repeat it over and over and over again. What a waste of time. As soon as you do the lesson, as soon as you understand something, take a note, take an example, do a problem. It will stick. It saves you hours of time down the road. So that's your master notebook. What about other things? Okay, so for the problem solving, and I'll take a different chapter. Here we go. Let's see, the quotient rule. This is a good one. There we go. They always start you off with the easy tests, questions. These are the warm-ups to get you their stretching exercise. And then usually 9 until 15 are the things your teacher's going to use. But here's what I want you to do. I want you to take a test and then realize what the type of questions your teacher liked to do. And then on the next chapter, I want you to spot those questions and focus on those questions. Because if your teacher's a hard questioner, he's going to use these tough ones. If your teacher realizes things are tough right now because it's a virus year, he's going to use these easier ones. And it all depends on your teacher. So, how do you do it? So now, when you do these questions, ideally, since it's hard to transcribe everything, and you might not have time, I want you to very least copy and paste the question. Then take a photo of your answer that you do in a notebook, and then grab your Paint or your Photoshop offline or something easy, and take a photo of your note, paste it into here. So I'll give you an example, and it's not a great example. How to solve a quotient function, and someone's going to have an image up here. And suppose, it's too bad there's no handwritten one here. There we go. That's good enough. Suppose you handwrote this after doing a question. You should then just take a picture with your phone and put it right under the question. And now you have a master notebook of that question that you can go back to, and you will clearly see the steps you did instead of repeating the question over and over and over again. You can also punch it into Symbolab if you made a mistake or to confirm your answer, and Symbolab will do the same thing. Okay, I can punch this exact same thing into Symbolab, and it will show me the answer. Okay, show me the exact steps. So that way, I don't have to page to the back of the book. Do it again for number 2. Do it again for number 3. Have you reached 30 minutes? Quit. Quit. Tomorrow, do the same thing. Quit. Do the same thing. Quit. Okay, so let's say you run out of time. Go straight to the end of the chapter. Pick the questions you think he's most likely to get and focus on them. Don't focus on reading the textbook. It's not going to stick. I have so many students who just memorize this and then go, there, I'm set for the math test. No, you're set for failure for the math test. All you've done is memorize the sugar. The teacher's going to ask you to bake a cake. You don't know how to bake a cake. So go straight to not 2.5. There's always a chapter test, a chapter review. Go through it. Say, okay, I know he's going to take like 3 of these. I know he loves these. And whatever, focus on those. If you can't do them, dig backwards. Dig backwards as best you can. But I don't encourage this because these skill sets you learn in this chapter are needed next chapter. That's how math works. They don't teach you something and then you never use it. It's not like history where you learn about the Civil War and it has nothing to do with the stock market crash in 1988. Now, some things do. The Civil War relating to whatever, relating to whatever, relating to whatever. Math, not true. It always relates. So you're really cheating yourself. If, however, you do this note-taking process properly, you don't know it now, but you're saving yourself thousands of hours. Now, in writing a test, I'll use the same example, actually, that we just had. All right. In hand, I want you to notice something. I want you to notice this. That equal sign is right over top one another. Yeah, he had something on the right, and he could just skip that. But that equal sign is essentially saying this is here the whole time. And at the very bottom, he should actually end it with this. And even a little therefore sign. Therefore, somewhere over here. Therefore, should go in there. This is equal to that. Sometimes you do a summary. Therefore, the ball was moving 2 over 5 minus, that's not obviously what this question asks us. 5 minus t meters per second. It's very important. Now, a lot of students, they'll jump, let's say, they'll do that one, and then they'll skip all this, and they'll just jump to this, and maybe they'll just forget that, and they'll do that, and plus everything's going to be handwritten with chicken scratches and whatever. So your teacher sees this and sees that, is not sure if you know the process, which is what he's testing on, so you're going to lose 2 marks there. Let's say you get the wrong answer, so all of a sudden you get the wrong answer. Now, had you had this in here, instead, your teacher will say, oh yeah, he knows the technique, he got the wrong answer here, so he loses points here, but he gets 1, 2, 3 points there, so he's going to get 3 out of 5. But had you not included that and gotten the wrong answer, 0 out of 5. So you're losing out on the 3 marks to show, yeah, I knew the concept, I made a simple number error. And obviously, it's going to be handwritten. What else should you do? Do one step at a time. Make it clear. So here they've put it all under the same denominator, right? And then here they've distributed the minus through to, well, actually no, they distributed this first. They left the minus there. And here you see 5t is there. Minus t squared is there. Th is minus th there. Minus 15 is there. Minus plus 3t plus 3h. So they distributed. And it's very clear what they did here. And they distributed this. So they distributed twice. Notice they've left the bottom the same. They didn't do too many steps. And if anything, you can do just this side and then that side in case you make a mistake. It's very easy now when you have time to go back and check your answers. You can go, oh, that's not a 5, that's a 6. And now you can correct your answer and correct something last minute and gain that extra 2 points that you would have lost. If you don't, and you just wrote it like this, you're never going to spot where you made the mistake. It's impossible. I can't see it, therefore I can't fix it. So you're just going to get the wrong mark because you decided to do it in your head or on your calculator. No, step by step and one change at a time. One change per line. And then a summary answer at the end. Always. If I ask you how many apples do you have and you say 2, you're actually being kind of rude. You should say, well, Mr. Peter, I have 2 apples. And that's a complete sentence. And that's what I'm looking for. Job interviews, that's a great skill to learn. What do you think you can, what do you think your best attributes are? I'm hard worker. No, you're not. You're a lazy speaker. You've got to put your best foot forward in a test. That's the whole point of the test. And yeah, tests aren't the best way to do it. I don't believe that testing is the best measurement of performance. But if you follow these tricks and tips, you will improve your chances. You will alleviate stress.